Hello everyone, welcome to my presentation. I'm Sara-Semantic from the University of Coimbra, and my presentation is about semantic mapping analysis of Digital Building LogBook and passport data models. Digital Building LogBook and passport is a repository for storing and managing dynamic and static information. It provides a repository for storing the building energy performance for whole life cycle of the buildings, and also provide a long-term and step-by-step renovation roadmap for specific buildings. And it's also a good repository to monitor maintenance activities and repair history. And also we can track and analyze the net zero emission building data. The main research objective of our research is to identify the categories and elements of the current digital building LogBook and passport data models. And we also investigated the similarities and differences between the existing and current models. We determined the quantity of information that can be collected from each model, and we also identified the most representative models in terms of how much information we can derive from each model. And also we investigated the main requirements of digital building, passport, and LogBook data models, and the challenge that exists around the existing models. And also finally we performed statistical analysis towards the create and integrated data model. Our methodology at the beginning, we started to find the DBL data models, and we use LogBook building passport, material passport district, LogBook building renovation passport, green building, and building certificate to find the main data models and main papers. And at the next stage, we just selected the papers at the high level. We did comparison, and we just compared the data models and the structure of the data models. And then for the next stage, because the current data models are in the PDF format, we converted the PDF models into Excel data sheets. And because we wanted to understand the format, the classification, the level of classification, and then we imported all of the data models and data sheets into the SQL database. And then we did the semantic comparison. At this stage, we wanted to investigate the similarities and differences between the classifications, that is include the group of the elements and also elements of each model by the other models. Finally, we did a statistical analysis, and we calculated the similarity percentage between the categories and elements of investigated models, and what are the main representative models in terms of how much information we can derive from each model. At the right side, at the left side, you see the project that provided the data model and the data structure, and you can see the summary of these data models, if the metadata is available, or the number of categories, number of elements. And on the right side, you see the DBL project that's already exists, but they didn't provide the data model and data structure. And we use semantic similarity method, semi-automatic, syntactical, and knowledge-based method to compare the current data models. And in this phase, we face different situations. Some elements were similar in their terminology, and in some cases, the elements were similar in their meaning, but different in their terminology. And we had to use the semi-automatic method and also knowledge-based methods. And some elements and categories similar in terminology, but their meaning, when we just use knowledge-based method, we found that the meaning are different. And also we identify the elements with uncertain meaning and also uncertain metadata. You can see an example in the semantic comparison that we did. For example, the floor area in the EU model, building description and characteristic category is equal to total floor area in the EUB model. That is, this project was published 2023 last year. And also net floor area in the IB Road project, general and administrative information. As another example, building information model and design and plans of the building in Extendo and EUB model is more or less equal to layout of the whole building, but they are different, they have a different terminology, but they are same at the meaning. Or in storage and energy supply and storage, when we just executed our query, we found these are similar storage, they have the same characteristic, but their meaning, based on the knowledge-based method, their meaning are different. For the next stage, we compare semi and knowledge-based method, and we have found that semi-automatic method for the comparison of EU to Extendo and EUB project perform better than it's happened for Extendo and EUB project, but for the rest of the project, knowledge-based method perform better. And we also calculated the similarity percentage of group of elements of different data models with the other models. For example, you can see administrative information in the EU model has 33% is similar to Extendo, and also 46%, the similarity percentage is 46 for finance category. But in overall, the similarity percentage between the the elements and the group of elements are low. And also we just did for the rest of the project, we compare Extendo to the other projects, and you can see again administrative information has a more similarity percentage value with the EUB project, and in overall Extendo, EUB and European Commission study, they are more similar together. And because the percentage of similar elements proposed by more than 3 models was about 6%, it was impossible to identify the key information that are needed for creating, for just compare the data models. We just used the Global Alliance for Buildings and Construction report, and we compare the main content of this report with the other data models. And in some cases, the group of elements, the categories, was similar to the global report. In some cases, the elements were similar. For example, the identification of the buildings in the EU model, we have unique building identifier, and we just use knowledge base because there are not a similar character in this when we wanted to compare these models. Or material inventory. In the EU and Extendo project, we have found that we have a building material inventory, but in EUB project, for each element, for each category, for example, wall, floor, and roof, we have this element material inventory. And the limitation of this project, the main limitation is about they are not aligned with the proposed categories with the global alliance, and also the current project provided diverse of categories and elements, And also there are not a detailed metadata about and clear definition about data type and data description. And also there are not a clear agreement regarding the building geometry, building unit and the buildings, and also building equipment information, for example, heating and cooling system. And also we have found that the real-time and sensor data and also building automation system has not been considered in the current and existing data model. Our future work would be create an integrated model by combining the existing and the investigated models. And also, we are going to include the energy performance certificate information, and we will identify the main elements of the DBL models according to the main application, and it helped us to define the main elements, and it would be applicable in different applications. Finally, we hope we can propose the comprehensive DBL framework. And this project was funded by FCT, Portuguese Foundation for Science and Technology. Thank you for your attention, and any questions?